Hey everyone, it's Mark. I am back for some PerfBits Weekly tips and tricks, which hopefully I have something really special I can flip over and do some cool things. My name is Mark Tomlinson. I'm the one of the co-founders and hosts of PerfBits, and we did some really cool stuff this week. We did an Ask Us Anything about performance. Henrik and I did that earlier this week on Tuesday. It was really cool. Thanks for everyone that joined. And this is the live stream. You can chat if you're actually, if you get the notification of what's happening here, if we're going live, hopefully it goes into the intertubes and then ends up, in front of your face. I'm testing out some automation stuff. It's always really fun, but it's happy to be with you here on a snowy Northeast Friday afternoon. I'm taking a break from my normal work just because it's been kind of intense and I missed last week. I apologize. Just because work has been, doing a lot of work. And actually the thing that I'm going to share with you in our tips and tricks today is related to the thing I've been working on to some extent. And we're going to talk about testing asynchronous services in the back end. And I'll describe what that is or what that looks like and the best I can in my whiteboard. But before I get started with everything, a shout out to the various sponsors of PerfBits. I'll say supporting sponsors who have been generous enough to support us, and we'll announce some new sponsorships coming soon, which is pretty cool. There's Tricentis. Neotis was acquired by Tricentis recently, so our good friend Henrik has come over. He's now working at Dynatrace, but he's working with PerfBits, and as our former Neotis Pack Neoload guy, go check out Neotis Neoload under Tricentis Neoload, which is great. And our longtime, one of the first sponsors, a friend of ours, Tim Koopmans and Evan, a very small team that was part of Flood.io, and you could still go check out Flood.io or now at Tricentis as well. So you've got cloud-based load testing, you've got on-premise, fantastic Neo load testing through the Tricentis world. And it just dawned on me, the back of my head, our good friend, the Quality Frog, Ben Simo, is actually at Tricentis as well, doing fantastic good work. So if you're not following Ben, the Quality Frog on Twitter, he's prolific and prolifically funny, very, very brilliant, and a long time. I remember one of the first PM things I did in the load runner role when I got a chance to do that was to have a long conversation with Ben. So that's go check that out as well. Of course, a shout out to our other sponsors, Catchpoint APM. If you didn't catch, no pun intended, the point, another pun intended, from Tim Kadlick, I think that's how you say Tim's name, Henry and the folks. There's a brand new rollout this week, incredibly exciting, pretty cool stuff in the web page test. So web page test is in the Catchpoint APM family. And there is some really cool visualization stuff happening. So go check out web page test, not to go on too much about sponsorships. So shout out and a thanks to the Catchpoint APM folks. You can go check out their website, which is really great. We put a bunch of that stuff down below. And our good friend Ryan Folk and the folks at Folk Consulting, get it? That's not just playing words. It's that kind of a Friday. Is pretty cool. So I'm an old-time performance test consultant, APM, performance engineering. I've done a lot of that in my career, from Microsoft to independent consultant, etc. But it's all about sharing your expertise with the world. And so Ryan and the guys, Brian Brumfeld's over there. There's a bunch of other really great folks working in the folk consulting world. So check out Ryan Folk Consulting if you need basically a coach, a champion, somebody to basically come follow through with implementation on tooling, implementation on processes, or even helping your executives to finally understand why performance is really important for the success of your company. We also had a conversation recently with Abstracta, Frederico Toledo, and there's a handful of folks at Abstracta that do some, you might not know, they do some really cool stuff behind the scenes, like those cool add-ins that you use in JMeter, like or in the BlazeMeter world. I wonder who wrote those. Some interesting stuff going on. So look for some cool stuff coming from Abstracta. The other thing that happened today, I hopped on a live stream with Leandro, a senior performer, also at PerfBits. He recently joined K6, the K6 Grafana company. I'm a longtime Grafana user. Sadly, I haven't had the opportunity to really work and use the K6 load testing products, but Leandro has. So he and Nicole had a live stream today. So if you're not on Twitch or YouTube following K6, they're not a sponsor, but they're cool. And just congratulations to Leandro for taking a role over there, doing kind of evangelism and stuff, which is really kind of fun. So thank you to everyone and all these the great people we have in the performance community. Because to be honest, even though we all use what are quote unquote competing technologies or competitive tools, the truth is all the tools are very competitive, and that's exciting. We challenge one another to come up and do more and new interesting things to serve the role of what we're doing, expand the power of performance testing and performance engineering as a message, and also just make every computer system a little bit easier and a little bit faster and easier to use. So good for everyone. I'm kind of Switzerland when it comes to that. All right. So our topic today is going to talk about async load testing. And to describe async load testing, I'm going to try to get all this right. If I go here, I go there, and I go there. Now you see me up in the corner, hi. Async load testing, different than asynchronous on the GUI. And Henrik and I talked about this earlier in the live session, in the Ask Me Anything session. Async from a browser standpoint is like there's multiple asynchronous JavaScript AJAX frameworks happening on the client. So if you have the browser running, and there's different objects in here, and they all can sort of have multiple threads and multiple connections making those work. Well, imagine that still has a stream of requests into an app server. And that app server, let's say here's the wonderful cloud, and here's another cloud, and there's lots of clouds, and maybe there's some local on-premise database resources and such. And in order to do a bunch of work, let's say we just talk about a simple entry point, step 1, step 2, step 3, and then it goes into this a chunk of code in the middle that says, well, I have to make a call back and forth to cloud A, and I have to make another call to cloud B, and I have to make another call to cloud C. And so there's this thing in, and so what happens when that, and then it finishes up by maybe logging some stuff to the database, maybe that stuff happens at the beginning and the end. But in the middle, there's this sort of section where your dependencies are external to our service, right? So to that service, and these different cloud providers or these different external services may or may not be healthy. They might not be fast. This one might be, 100 milliseconds. These really have their stuff together, right? There's 100 milliseconds, 10 milliseconds, that would be really fast. But let's say 100 milliseconds right there. These guys, 500 milliseconds. They do a lot of work. They do a lot of processing. Get at 500 milliseconds on service B, back and forth, maybe get 500. C, typically, you'll have the majority of the time it's 200 milliseconds, but every now and then there's some massive work, there's some limitations or some thresholds. There can be like the number of endpoints. It can be a service provider where if you pay for more throughput, you get more throughput. So sometimes we push right up against that threshold and we get like a 60-second timeout. Or it's completely unhealthy. Like these guys, every now and then they just completely, they go out to lunch, right? Now, here's the goofy thing about synchronous architectures. If you haven't really adopted asynchronous stuff, you would have to maybe do a thread to do a call to service A and wait for that to come back, then that same thread. So you could serialize this. So one option is you do you do it in synchronous fashion. Let's say we do we have to do A, B, C in serial order, which is really inefficient, right? Because what if these are fairly independent? I don't need data from cloud A, service A, to make the transaction to service B, to make this transaction to service C. So I could do it in parallel. So we could still do them in sort of synchronous, meaning I want to call, here's one thread calling A, B, and C. Here's sync multi-threaded. I'm going to make those calls 1, 2, 3 different threads, and those 3 different threads go A, B, and C. So synchronous multi-threaded, now I can fire up the call to A, the call to B, the call to C at the same time in parallel. And you're like, wow, that's saving a lot of elapsed time to get all of that work done. That's great. But it's still synchronous, but you're doing it in parallel with multiple threads. So most of our applications, us as an industry, not where I work, but a lot of what people have built have been multi-threaded, very large applications that consume a lot of memory. Each thread you build takes up memory. And so we have tons of threads. And then let's say you have some of this stuff that's 60 seconds, 500. Some of these calls, you have a thread that's just sitting there taking up memory on the server right here, waiting, doing nothing. So it's not consuming CPU. It's not doing productive work. But if you've got a very large data set, something cached, that thread has to do a bunch of work and it's taking up memory, and you're running a couple thousand transactions per second into this box, that's a tremendous amount of memory. Those threads are sitting there, taking up a bunch of time and doing nothing. So you're like, all right, okay. So many, many years ago, I was working at PayPal, I think, and we're doing a bunch of Java, and we had invented this idea, well, maybe we need to have different thread pools, because if I have a whole bunch of threads and a limit on the number of thread pools, that 1001st thread comes in to do this work, and it's like, hey, I can't get a thread in the thread pool because I have to wait for a thread to be free from the worker pool. So now you've got denials of being able to do the processing because you don't have a thread. There's another concept you'll hear in PerfBits that we talk about a lot called latch time. So let's say service A, B, and C are running beautifully, 200 milliseconds, 500 milliseconds, 100 milliseconds. And we have 1,000 transactions per second coming into this server. Everything's synchronous, but the minute service C, and I'm going to circle this right here, goes to that 1 minute response time, all of those threads will come in and be like, going to A, going to B, going to C, or in parallel going to C. Hey, I'm ready to finish up the last part of my processing and return to the client, but I'm sitting and waiting. I'm actually sort of hogging the thread pool, sitting there waiting for this 60-second response. And then you're like, well, can I time it out and retry? Well, if I retry, then I just make the storms all happen again, over again. So I have a retry storm. That's not good performance. That's not good at all. So it exhausts the thread pool because you have to have a thread sitting there waiting, doing nothing, and you can't do any more productive work because I actually have 1,000 threads sitting and waiting for that 1 minute thing. And the next one that comes in, everyone's just waiting on a super, super slow transaction. So we have a lack of traffic segmentation. So we can't have fast requests stay fast and slow requests stay slow. That slow request backs up and hogs database connections, hogs the thread pool itself. So asynchronous wise, not to go look up task-based programming. In Java, it was about futures, and you could have sort of work items. It's async await would be the task-based programming in .NET. The idea being that you can not necessarily spin up threads, but internal here to async and await, you actually make up, the way I understand it is, I kind of have a little messaging, a little queuing, a little task message or a task table inside my service here, where if there's work to be done sort of on the queue of work to be done, a thread will wake up and go do step A. And then when it's done, that thread is relinquished. It doesn't actually need to stay waiting because it's done its work. And so if we're waiting for something over here on service C, the thread's like, well, you're waiting. I'm not going to hang around as a thread and wait for you. I'm going to go do some other work because we asynchronously make this call over to service C and we await a response. When that response finally comes back, then a task will pick it up and complete the rest of the process and the request transaction is done. So async await becomes really, really hard to test for a couple of reasons. If I take this same concept, right? So I have my service in the middle, there's my 3, here's my little async world, and I have A, B, and C. And if I want to test from a load generation standpoint, here's 1,000 TPS, and let's say I'm doing it in a tool where I have 1,000 threads, and I have just one pool of traffic coming into the server, let's say it's in JMeter or whatever your test tool is. Those 1,000 threads are sort of matching up to the the asynchronous part that's running inside my service. And we're going back and forth to A, back and forth to B, back and forth to C. If I have JMeter configured and I have one thread pool, that thread pool I have within that running, I'm going to have some requests that are super fast on A. I'm going to have a bunch of threads that get requests that are super fast on B, and maybe they're questionable. And I'm going to have slow stuff on C. But actually, there's fast C as well. So sometimes, remember, this guy is like 200 milliseconds, and other times it's like 60 seconds. So in C, I have 2 modes of operating. So given the threads that are all running in JMeter, it's kind of hard to see in a single dashboard what that looks like. So I have 1,000 threads, and they, depending on how we configure this, sometimes the thing comes back fast, sometimes it comes back slow. I don't really separate these kinds of things. So to describe the load testing that I did, my recommendation is that I actually separate JMeter thread pools, and I have a thread group 1, thread group 2, thread group 3, thread group 4, to push these threads in JMeter are always fast. And so, and for the most part, let's say that request comes through and it goes to A and comes back. Like I use, it could be a store ID or some entity or something that says this guy will always hit A and be fast. So those, let's say in this case, I have 100 threads running on fast A. They'll always be fast. And then fast B, I should have another color, purple. So purple, fast B comes in and it goes back and forth to B and it's fast. So if, let's say again, I've got, 100 milliseconds running over here and I've got 500 milliseconds over there. And then here in Redland, I love my Sharpies. Yeah, sponsored by Sharpies. 200 milliseconds or 60 seconds. Yeah, exactly. That could be bad. That's huge, 60 seconds, a full minute. In C, I could have, let's say, I'm going to do like a dotted red line. Comes in and gets 200 milliseconds. And then a solid red line comes in and gets 60 seconds. Now, if I'm going to go do a bunch of load testing, one of the hard thing that's really hard to do, there's 2 things to it. The first thing to keep in mind is if the C service, and I use imposters, I'm going to give it a quick shout out to Mount Bonk. There's a bunch of different mock servers out there. Also commercial products, ITKO, Parasoft, HP has a virtual service virtualization. So what I did, this is my system under test, right? The actual piece. But I created an imposter A, imposter B, and imposter C in my test environment. And they're dummy responses, so they just have like a wait behavior. Here, I have blue on here. I got to get some blue on here. So this is a wait behavior that's going to wait n number of milliseconds to mimic, what that's doing. And I actually have totally separate imposters or even pools of imposters set up to actually run A, B, and C. And when the load is running, when I fire up all of these groups, I will start at the beginning of the test, sort of everything runs fast. everything runs at maybe the lowest one here is 100 milliseconds. And so I get all of my threads sort of ramped up, and then everything's running in the imposters at 100 milliseconds. And then the timing wise, like you can do it with like a certain field or parameter that you set in, you change the payload after n number of minutes, then change the ID or change the payload so that this guy will start responding differently. So this guy's going 100 milliseconds. I see 500 milliseconds on the graph. Let me put it this way. So I should see 100 milliseconds going really fast in A. I should see, that other one was pink. Was it pink? It was purple. Yeah, purplish. So I see another one that's running at like 500 milliseconds. And then I see the red one that's running at like 200 milliseconds. And then after 60 seconds, I see, after a while, I see one running at 60 seconds. But I'll delay the ramp up and running of this until, let's say, the 60-second ones will fire up in the middle of the test, so that everything's running great. The threads that are servicing service A are running fantastic. The threads that are servicing imposter B are running fantastic. Even the 200 milliseconds on imposter C, everything's cranking along for the first couple minutes of the test. But when I add these hogs, these service C, imposter C at 60 seconds with the super long latency, if I'm not asynchronous, I should see that all 4 thread groups, all 4 transactions, everything slows down, and what you'll see is request queuing in the service. So look at your request queuing, and the latency could even time out. So you'd see errors flow back to here because, hey, I went to the server, went to do my work, couldn't find a thread to do my work, so I just went home and said, sorry, 503, server busy, something like that. Cool. Now, if I implement async, you know what should happen? As the transactions ramp up, I should see all of the transactions for imposter A get 100 millisecond response time all day long, right? So the green guys will run fantastic all day long. And I should see all of those. The only ones that should show impact or slowness after I ramp up these 60-second hogs is the 60. I should see the 60-second guys show up, and no other healthy services, fast A, fast B, even fast C, shouldn't be affected by that slowness. And that's the idea of an asynchronous test setup. What I do want to show you, if I get this right, let me go here, turn that off, turn that on, and I'm in the wrong screen. So let me get over here. Hang on, there we go. There. Now what you're looking at on this screen is part of the test that I've set up, and I've kind of expunged some of the data. But I have imposter A, imposter C, imposter B and C. The one that you see on the far, let's see if you can see that. Am I looking right? Let me get that right. No, that didn't work. I got to turn that off, turn that on. All right. I'm not going to be the little image in the screen. On the far left, you see the green color actually shows up as the key. That's kind of funny. Actually, I can do that, then do that. Ha! There we go. Now this looks better. So what you see down here is so down on the left side is no latency. And for this test, I had no latency, meaning it didn't even make a call to imposter A. But for argument's sake, imposter A was running really, really great. And imposter, the one in the middle is like service B. So that had more latency. So you see on the left, response time's really, really low. On the other side, it's really quite fast. And I don't know if I can probably zoom in and I can show you what this looks like before the other imposter showed up. So yeah, so here you can see like there is a transaction running underneath there. It's like a health check, so it's super fast. But here's like service A is running at 100 milliseconds, and service B, imposter B, is running fast at like 500 some milliseconds. And then after a while, if I zoom back out, after a few minutes of elapsed time, we run into we fire up those hogs. So you'll notice everything was running great, and then at like 3 minutes, at right before 3:56, we start running and ramping up the threads. Actually, if I scroll down, you can see here's the threads running along like great. And then we ramp up a bunch of these super slow threads, which is just like a 20-second kind of thing. And then look at the impact on throughput. It just backs up into, and this is running synchronous. Keep in mind, this is running synchronous. We don't have any optimizations for async running in this code. So when you fire up that imposter C, when you finally turn on, hey, let's put some really slow threads into the pool, boom, look at the impact. Everything goes to like 30 seconds, a minute. It impacts, everybody gets impacted. And keep in mind, the imposters that are behind here, like the imposter fast, it goes from responding at 500 and some milliseconds really fast. And then when those slow threads show up, it's not slowing down because of the imposter. It's slowing down because of local resources. It can't do its work. So the thread pool shoots up to like 600-700 threads, where it wouldn't normally do that, right? Which is pretty wild. At the same time, if I go to the next screen, now this is just a different view of the same kind of imposter setup. So I've got left and right, and here this is fast and slow. So it's like imposter A and imposter C. And again, after a few minutes of running, I actually switch from imposter C running at 200 milliseconds. I actually do a little flip in there. All of a sudden, imposter C goes from running at 200 milliseconds to running at like a minute. And so, boom, you see imposter C goes up through the roof. And so its response time is really bad. Actually, it's like 30-some seconds. It's just sitting there and it's getting errors and all sorts of stuff, and it has issues. But all my other traffic that's running on imposter A, imposter B are really, really fast, super fast, which is really nice. And that's what you want. This is asynchronous, but it's still not perfectly healthy. You'll see there's some spikes in there, but the concept that I'm not backing up into the thread pool on the service, and keep in mind a couple of different things I've done here. You'll notice like these graphs are duplicated left and right, and even back in this other, let me see if I can get there. I gotta get myself out of the way, hang on. So if you look at this other graph, I actually have 3 separate load generators. One is called Toreador, one is called Caspian, and one is called Panshin, which are from the Expanse ships in the Free Navy. But the nice thing that makes it totally discrete is I've got 3 different load generators totally independently creating threads. And so even though they hit the same server in the center, those requests are completely independent. So I'm not even having slow requests in load generator 3 affect the threads that are running in load generators 1 and 2. The load generation is also segmented. The imposters are segmented. They run on, if you can, on different machines, but at least on different ports on the back end. So run them as 3 discrete services or processes in the back end. And so you want to the only thing that should have the contention that you're testing under load is in the middle, is that service. And so if I try to, let's see if I get myself out of this. Go back. No, not that. I don't want to do that. That was the wrong music. I don't want you to do that. Let's make sure that music is not. Yes, it is happening in the background, isn't it? Yeah. Stop that. Stop that. Sorry about that. Trying to juggle too many things at the same time. So if I show you the overhead screen, the only point of contention you would want is in the middle, and in this example would be 4 separate load generators, or at least 3 separate load generators with 2 different modes of imposter C running, 3 different imposters, but the main contention for load is happening in the middle. So that's my recommendation. And then all of your graphs, all of your monitoring and results are very independent. Like there's no questioning whatsoever. Don't get lost. Hey, you know what? This JMeter instance 1 is different on different load generator. There's no reason those threads should be backed up unless there's some contention happening in the middle. And that is a small approach. And the other thing I'll just reiterate again, your load scenario, in almost all concepts, my tip for you on every load generation, every performance workload scenario is you're doing an observation where you're pushing a system intentionally from a healthy state to an unhealthy state. And so that's why we ramp up. That's why we're trying to observe what happens as a system transitions from running in what's considered a healthy way, healthy threads, CPU, disk, memory, network, etc., no exceptions, and we introduce something to push it to an unhealthy state, a spike in traffic. We ramp up to a point where it exhausts one of those resources. So a nice gradual stress test. Or in this case, we get everything running nice and healthy, and then we switch one of those imposters to start running really slow, which happens in the real world. A real service, there's outages, all of a sudden, whoops, something happened and the circuit went down, or they have a database problem. I mean, the cloud goes out. So in the real world, I didn't change anything. I'm sending the same requests, and I expect them to come back in 100 milliseconds, but all of a sudden, boop, they're taking a minute. So, and what's the impact back on my system if all of a sudden I'm backing up these threads? And what does that do to the client all the way back? Now the client, there's a whole piece in the client that's not rendering. And is that asynchronous? One of the advantages with rendering asynchronous on the client side is you can put in rules that say, if something's not ready to render and display to the end user, don't display it. Like there's stuff that goes wrong behind say an Amazon web page. You never know it went wrong. You'll never know because they're like, we've rendered everything that's going to look good. And if something's supposed to be on the page and it didn't make it, you won't even know. It's like a good jazz musician. You won't even know the mistakes that they make. It sounds great. I thought she tried to do that. I thought, that was brilliant. At the same time, that person's like, I totally screwed up that song, but the audience will never know. And that's kind of the brilliance of handling transient errors and exceptions and things in back-end systems in an asynchronous fashion. If you have any questions, I'm following some things here. Hey, Scott Morris, shout out to the load tester himself. Check out the performance tour because it's awesome. And he's got all sorts of other cool stuff. So great to see you, Scott. And thanks for joining PerfBits Weekly with me, tips and tricks. And I'm happy I got to you guys on a Friday, a little late on a Friday. And I'll see you next week. And we'll talk about something else. You can send me an email, perfbits@perfbytes. That doesn't. You could say the number 1. Mark@perfbytes.com. That works as well. Check out Leandro's show, and Leandro has a book about load testing, which is pretty awesome. James has put out if you're hiring anyone, if you've got jobs. We do have a Discord channel with sort of a jobs channel and that kind of stuff. Scott has a fantastic Slack channel as well. There's a lot of good places to collaborate with performance people in the performance world. But I was giving a shout out to James Pulley, who also runs the PerfBites Press. We have 3 books. He has 3 books that he's put out. And it's about hiring and interviewing performance professionals, which is, don't get him started talking about that because he'll never end. He's very, very, very passionate about that, which is really awesome, actually. And the book is fantastically written. So yeah, check that out. And I will see you next week. Pretty casual. And have a good weekend. If you're in the Northeast getting snowed on, or if you're in Florida where it's getting cold, holy cow. Scott, it's supposed to be like 40 degrees down there. And I saw this article about like iguanas dropping from the trees. I don't know what that's about. But anyway, talk to you guys later.